Right, for the cos double angle, right, there's actually 3 results which we should try and remember, okay? And you can see I've written one result down here, okay? In fact, this result is the sort of most important one, because if you know this result, you can easily work out the other 2 results, okay? You can easily get them, right, using an identity we learnt in C2, okay? And I'll show you how to do that now. But this one, right, this one is the one we get from this trig identity up here. So suppose, for instance, you forget this in the exam. Well, there's a way of working it out, okay, which is really good, isn't it? You can work it out using that identity. So let's just copy that identity down, right? So we've got cos A plus or minus B, okay, equals. Now, what I like about the cos one is, in a way, it's nicer because they group the causes together. And they group the sines together, don't they? The cos A, cos B, sin A, sin B. What's a bit weird about it, though, is that the plus or minus sign are sort of opposing what we've got here. So whereas we've got plus minus here, it's the opposite decision there, then it goes minus plus, okay? So that's something we look out for now. So when it comes to COS2A, right, remember we could write COS2A as A plus A, right? So then if we think about it here, in this situation, then I'm setting B to equal A, aren't I? Okay, B becomes A, right? And I'm choosing the plus option, aren't I? I'm choosing the top option there, okay? So then if I just put it into this, I've got cos A, and then of course that's going to be cos A, yeah? Because B, remember now, I changed that to an A, okay? So that I've got A plus A, which gives me 2A. And then, this is the bit you've got to be conscious of here, because it's plus, right, here, so that we can get A plus A, so because we're choosing the plus, notice this is the top option there, which means we've got to choose the top option here, right, they've got to correspond, so because I'm choosing the top, I've got to choose the minus there, which is on the top. And then, of course, sin A, and then sin B, of course, the B becomes an A. And you get the result, you get what I've written here. Okay, so remember how easy it is to work out in the exam. Cos A times cos A is cos A all squared, isn't it? Which we write as that, cos squared A. And sin A times sin A is just sin A all squared, so we just write it as that, sin squared A. So how easy is it, yeah? How easy is it to do this, yeah? Even if you can't remember this result from the exam, you just work it out straight away using this trig identity on page 4. It's really simple. Now the other 2 results, okay, we can just derive the other 2 results from this here. It's quite straightforward, because if you remember from C2, what we learned from C2, we learned that sine squared A plus cos squared A equals to 1. Okay, and when we learned that in C2, we learned to rearrange this, didn't we? So we could write sine squared A as 1 minus cos squared A. You just took the cos squared over, so it comes a minus. Or you could have written cos squared A. Okay, going back to this here, you could just take the sine squared over, so it becomes 1 minus sine squared A. So this is helpful now in my result up here, because what I can do, I can just rearrange it. So for instance, let's look at the other results then. COS2A, well, if you think about it, cos squared A is just 1 minus sine squared A, isn't it? So I can write 1 minus sine squared A in place of that. And then of course I've got this minus sine squared A at the end. So then all of a sudden then this becomes 1 minus 2 sine squared A. Okay, so that's my second result. Okay, and what's nice about this result is that it's just in terms of sign, isn't it? The third result is doing the other substitution. So if I go back to this here, okay, keep the cos squared as it is, but then you take it away, take away sine squared. Remember, sine squared A from that rearrangement is just 1 minus cos squared A. Put it in a bracket. It's important you put it in a bracket because we've got to take it away, haven't we? Okay, we've actually got to take the sine squared A away, which is 1 minus cos squared. So that would be cos squared minus the 1, minus the minus becomes plus cos squared A. So we get 2 cos squared A minus 1. Okay, so my two other results I can write up here. I've got 1 minus 2 sine squared A and 2 cos squared A minus 1.